allows us to get really, 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 really close to a specific value or like a specific moment, like we were looking at when we were dropping our bowling ball. So in our graph, we looked at my x values are approaching 2. What are my y values approaching? Well, we decided that we could just plug into for my function that I gave you, and we just get 4. However, we then looked at one that we couldn't just plug into. So what do? Well, we looked at our graph, and we decided that our y values were still getting really, 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 really close to 2, okay? They just weren't quite actually 2. Now, the other way that we can look at this, okay, we talked about our limit notation. So remember that we read the limit of f of x as x approaches a. Basically what that means is we're looking for what does our y value equal as our x value is approaching a specific value. But it doesn't technically have to equal it. It just has to get really, really, really close. Our notation for this is the limit as x, that's the little arrow, just a bad arrow, goes to a of f of x. So here are a couple of graphs. So this first one, it actually has a point at the designated a value, and so like this point would just be a comma l, which is okay. But now notice here, let's say that this value is at k for where this dot is. So notice that at a we actually have a hole in our graph, so my limit is still going to approach l, okay? Because my graph is still getting really, 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 really close to L. But if we actually plugged in A, we would get out this K value instead. So remember that it doesn't actually matter what it equals at that value. It matters what it's getting really, really close to. And then lastly, f of A is actually undefined, which is okay. But our limit is still getting really, really close to that. Yes? Are we all okay with that? Now, the other way that we can look at these, so going back to the same one we looked at yesterday, we want to look at it with a table. So you need out a calculator. You can use the greenish, bluish scientific calculators. They have a table function on them, or a graphing calculator. Either one will work. So, do we know how to make a table in our greenish bluish scientific calculator?
No idea.
No? Okay. Well, I'm about to blow your mind to show you how. Alright, so I'm going to tell you how to do it in the scientific first, and then I'll walk you through the steps of the graphing just in case you have that one. Okay? So, on your scientific, you're going to click the table button, which is on the 3rd row, 4th column, right there next to clear. Then you're going to type in whatever function you're wanting to use. In this case, our x divided by the square root of x plus 1 minus 1 is our function. You're going to use the little x button that is right next to the 4 in order to put your variables. Alright, so then you're going to click enter once you've typed all that in. And it's going to tell you where you want to start. Normally, it's a good place we start like a little bit before 0 because we're trying to approach 0. So we can say -1. Let's go. Our step, which basically is like how much it goes up by each time, is at 1. And then we're going to scroll down and click enter on OK. And that's going to give you a table. If you scroll up, notice at -2, it gives you an error. At -1, we are at 1. So again, remember that we're trying to calculate what it is at at 0. We can't actually plug in 0 because notice at 0 is undefined. We get an error, okay? But we do have at negative 1, it is 1. And if you scroll over at 1, it is 2.414. Now, thinking about how we're trying to get really close to 0 is 1 and negative 1, either side, very close to 0. In the, potential numbers that we could get by 0. No. So what we want to do is you're going to go back and you're going to click table again. We're going to use the same function, so you're going to click enter. But now we're going to change our step to 0.1 and then click OK. Because now we can get some values like negative 0.1 instead, and that gives us 1.949. And on the opposite end, 0.1 is 2.049. Yes? And you can go back and keep changing your step to get closer. Now, if you are on the graphing calculator, first, you need to make sure that you are back into function land. So go to mode, make sure that it's not on parametric or polar, since some of them are still on that mode. Okay? We're going to go to your y equals. And again, you're going to type in this function. Remember that if you click alpha y equals and enter, it gives you a fraction. That way you don't have to use the division. Okay. You want to go to second and then window. Because again, we want to change it to be that we're starting at, say, 0. But we said we want to get closer. So instead of 0.1, let's change it to 0.01 for your little, where it says the triangle table. That just means, again, the step, how much it's going up by each time. And then you're going to click second and graph. So now it gives us 0.01 is 2.005. And on the opposite end, negative 0.01 is 1.995. So were we all able to figure out how to work our table with whatever calculator we're using?
No.
Yes? Okay, so again, we already looked at the graph of this, but we should be able to see as our values are approaching 0 for our x's, what are our y values approaching? 2, which is what we got last time too, but we just clarified. So we still get 2, which makes sense. So I could now give you a table and I could say as the limit goes to whatever, what are our y values getting towards, and hopefully we can kind of see, like in this case, those values are getting closer and closer to 2. Yes? So tables are just another type of representation for math. We actually have 4. What are our 4 representations of math? So a graph, so graphical. A table, okay. There's actually another one up there. What are these? An equation. So symbolically or algebraically, yes. And there's one more. It's the one that y'all like the least. Applications or just with words, right? We can always represent a scenario with words. Alright. So, next up, you You don't have to write this down. It's very wordy. Basically, all that it says is notice that when we made our table, yes, what type of values did we have to look at? Positive and negative. So I had to look at things that were to the left of my number and things that were to the right of my number. Now, when I'm doing that, they have to equal the same thing in order for the overall limit to exist. So if I'm going from the left-hand side, we put like a little negative symbol. If I'm going from the right-hand side, we put a little plus symbol. And those two things have to equal in order for the overall limit to exist. Because if it's going towards two different things, then we can't say which one it is because they're different. Does that make sense? So, let's look at some more graphs. So, here we have what type of function there? What? It's a piecewise function. So notice we have two different pieces of graphs. Okay. In calculus in general, you're going to deal with a lot of piecewise functions. Okay. So it's good to remind ourselves about it. So now, notice on our first one, like I said, so in part A, it asks us for the limit as x approaches 2 from the left. Again, that's what the little negative symbol means. Okay, but this time the left doesn't necessarily mean negative things, right? Because we want to be really, really, really close to 2, but on the left-hand side. So what type of numbers are really, really close to 2, but on the left-hand side? 1.9999. On the right-hand side, we would be looking at 2.0001, so forth, okay? So if I look at the graph that is on the left-hand side here, so again, we're approaching our 2 value. What y value does it look like we're getting closer and closer to at this hole? So we would say that this equals 3. Likewise, if we look at the limit of 2 from the right, what does it look like our y value is approaching? 1-ish. We'll go ahead and round. Yes? Are we all okay with where we're getting those values from? Now, are 3 and 1 equal? No. So what does that mean about our overall limit? That it does not exist. Yes? Alright, in your groups, I want you to try part B, which is dealing with the x value of 5 now instead. And go.
What's that TV? What's that straight? Don't worry, I'll see if the local TV. Say you're not doing it. Say. Say you're not. Sorry, I don't talk to insects. Yeah, I was getting.
And then
Number
the
1.
right of 5, it's also getting
Why'd they start without me?
So the limit is like 2.
Wait, why would 1?
Why would
Oh God. Why isn't it 1?
Because it's not at 5, it's like getting closer to 5.
Oh.
So, what is our limit as x approaches 5 from the left?
I have a yearbook for Brooklyn Davis.
What is our limit as x approaches 5 from the right? Also 2, which means that our overall limit is 2. Now, if I asked you what is g of 5, what does that equal? This is at 1, right? So this would actually be like 1.5, right?
Sure.
It's this dot right here. So this dot is our function value, okay? Because that's where the actual point is at 5, 1.5. However, that's not what our graph is getting closer and closer and closer to. It's getting closer and closer to that hole, which is at 5, 2 instead. All with me there. Questions on any of that? Right. Let's look at another interesting one. Okay. Now here, what type of function do we have on this first one?
Absolute value.
Absolute value. All right. So, what happens, or what do we have to do when we have an absolute value? So we're gonna have to look at two different equations. So what type of numbers, when I have an absolute value, okay, that are before 0, okay, what type of numbers are we looking to be? Before 0 gives us what? Negatives. So remember that our two cases with an absolute value are our positive and our negative. So we have to look at the negative case to the left of 0. Are we all okay with that? Now, what is x divided by x? 1. But we also have a negative there, so we just get -1. Yeah? Which basically means that we just have a horizontal line at -1. Yes? So what is our y value always going to be getting closer to? -1. So our answer here is just -1. However, on the flip side, from the right-hand side, which case do we want to choose for our absolute value? So x divided by x is just going to give us +1 this time. So same thing. So are my left-handed limit and my right-handed limit equal to each other? No. So it does not exist. You could also, like we've been doing, look at the graph of this to help us out. So here's what our graph of this looks like. So notice that to the left, we are at -1 always. To the right, we are at 1 always. Yes? And so if I look, my two limits don't meet up, which is why it does not exist. Now, this other one says discuss the existence of the limit. We gotta decide if it exists or if it doesn't exist. So what type of graph is 1 divided by x squared? What do we have there? Not parabola, because where's our x squared? In the denominator. So that means it's a fraction. So we have a rational graph, yes, which has asymptotes. So what do we have here? Again, we're wanting to get closer and closer to the x value of 0. So what is happening to our y values as we get closer and closer to 0 from the left? Okay, what's happening as they approach it from the right? They keep going up. So what is it going towards, or what is it approaching, like we said? Infinity, okay? So if we wanted to, the limit of this technically approaches positive infinity, yes? However, if we go back to like our definition, right, this says that our left-handed limit and our right-handed limit have to equal L, and L is a value. Is infinity a value? No. So the limit does not technically exist, okay? But we can say, we can use this notation to describe the behavior, to say that it's shooting up forever. But we can't actually say that it is infinity, because in order for it to exist, it has to be an actual number. Yes? Are y'all okay with that idea? I can't have unbounded behavior, which is what asymptotes are. Okay? Now we're going to look at my favorite problem. Are we ready? It's a fun one. What do we got here? Something not very fun. Okay. Yes. So again, what have we been looking at? Limits, yeah, but what have we been using to look at those limits? The what? The graph. Okay, or the table. We could look at either one, but the graph is going to be a little bit easier to look at. So, let's go ahead and graph this bad boy. It's a little much. 1 minus squared of x. Alright, so looking at this from the left-hand side, what is happening to our values? They're getting bigger and bigger and bigger and bigger. So from the left-hand side, it would be approaching positive infinity. Because then from the right-hand side, what's happening? It's going down. So it would be approaching negative infinity. So what we would say is that the limit as x approaches 0, we said from the left of f of x equaled positive infinity, but the limit as x approaches right from the right of f of x equals negative infinity. Therefore, this overall limit does not exist. Are we all okay with that?
Yeah.
Now I'm going to